Today we're going to talk about the recording of costs in a business. A business that does not know its costs or cannot measure them accurately is a business that is destined to fail. Let's begin with some basic categories of costs. For example, the accounting for materials. So typically a company will, we're talking about a production company here, which has to buy and process materials into finished goods and then sell the finished goods. So they should have an orderly process and procedures in place for the ordering and receiving and storing and insuring, of course, and issuing such materials into the production. So whether this is done in a manual record keeping, in a simpler organization, or in a highly sophisticated IT system, doesn't matter. The same principles occur. There has to be responsibility, and there has to be verification of each of the steps that take place. Now, here's some of the key documents that are associated with the materials handling. One is the purchase requisition form. Requisition is a kind of internal form which gives the approval for materials to be purchased. Clearly, this would be done against some sort of budget, so that companies aren't just ordering without limit all sorts of materials. Otherwise, the company may run out of cash. The result of a purchase requisition form is to issue a purchase order. And this is an actual order for description, quantity, price, etc. of things that the buyer is going to intends to receive from a supplier. So this is fairly standard purchase order. And then there's something called the goods received note, which again, when the buyer receives the goods and confirms that what they had wanted to buy has actually been delivered. In other words, the order has been properly executed. And the GRN will have an order number, description of the goods, and then the quantity ordered and quantity delivered. So goods received note is not concerned with the price of the goods. It's more concerned with the actual logistics of getting the right stuff, the right quality, the right amount of it being delivered. The financial department will be concerned with settling the invoice and paying the money. Now, once the goods are received, they have to be released inside the company based on some requisition or internal authorization form, and then the materials travel their way through the inside the organization as they get processed, moving from one stage to another. Here's some accounting entries we can think about for materials inventory. Materials inventory goes up against a debit to the materials inventory account, and a credit indicates a decrease in inventory. The debit and credit system is something which at this point should be very familiar to the candidate, and it's just a matter of practicing and seeing this at work in as many different types of situations as possible. Now, with regard to materials accounting, there's also a very interesting formula that we can learn here, which is concerned with the economic order quantity. In other words, it's to order just the right amount of materials so that one can keep ordering costs and holding costs, the costs of holding things in the warehouse at an optimal level. In other words, to minimize the overall costs in connection with ordering things. Now, we might add that the idea is to minimize costs not only associated with holding inventory, but also the ordering costs, since every time we place an order, it costs us money to order materials. So let's have a look at the key variables that enter into the picture here. When we talk about total costs, we're talking about the Q being the order quantity, D being the quantity of product demanded on an annual basis, P the purchase cost for 1 unit, and here are the costs relating to ordering. There's a fixed cost per order. That's for the transaction. It's like a transaction cost. It's not doesn't include the purchase price itself. And H is the cost of holding 1 unit for 1 year. There's a cost to having to keep in one's warehouse materials, because that's tying up money. So the total cost function, we could say, is the purchase cost of the materials themselves, plus the total ordering cost associated with obtaining those materials, and the holding costs once we have those materials delivered, the costs that are connected to keeping them in-house. And in fact, we could convert each of these into algebraic expressions based on the definitions of the various variables shown above. And this is the total cost function that we have to minimize. Here, just one word to make this completely intelligible for those people who may be a little bit challenged mathematically. The purchase cost, P times D, makes intuitive sense. It's the quantity of the product demanded on an annual basis, D, that's the number of units, for example, times the purchase price for 1 unit. So P times D will be the total amount of money that we have to spend for the goods themselves. Now, the ordering costs. Let's think about this. What does it cost us, the transaction costs connected with ordering? Well, we have a fixed cost per order, C. And that fixed cost per order has to be multiplied by the number of orders that are going to take place. How can we determine what the number of orders is going to be? Well, the answer actually lies in the relationship between Q here, the quantity ordered, and D, the total quantity that we need to have over a period of a year. Let's think about this in terms of a timeline for a whole year. If for a whole year we have a demand for 1,000 units, imagine if we were to order 10 times a year, 100 units. 100 units times 10 orders per year would equal 1,000 units. That would be just right. But there are many, many different ways to achieve 1,000 units. We might place more frequent orders. In other words, instead of 10 times a year, we may order 20 times a year, only 50 units per order. You can see that 50 times 20 is also equal to 1,000, just as 100 times 10 is equal to 1,000. So each of these combinations of order quantity, these are the order quantities, and changing. The order quantity changes, but the total amount demanded, D, remains constant. So what else is changing when we change the size of an order? The bigger the order size, the higher the Q, the fewer times we need to order. So 10 and 20 in this case are representing the number of times that we order. And in fact, we can say the number of times that we have to order is a function of D, the total amount needed over a year, divided by Q, which is the size of any one order. One can see here that 1,000 divided by 100 is equal to 10. So the number of orders 10 is equal to 1,000 divided by 100. In the second case here, where the order quantity is 50, if we divide 50 into 1,000, in other words, D over Q, 1,000 over 50, we end up with the number of orders necessary of 20. So now we have very neatly expressed the ordering cost as being C, the fixed cost per order, times D over Q, which represents the number of orders made in a year. Having done that, now let's ask ourselves what the holding cost will be for a year. Well, the holding cost will be the cost of holding 1 unit for 1 year. That's H, that's no problem. The question is now, how much do we hold in the course of a year? Well, here we've got to make a simplifying assumption. Imagine that we make an order of Q, and we receive Q, that becomes our maximum amount, and we work down Q over time until it gets to 0, and then we order again Q, and we work it down to 0, and so on. We can see here that the average quantity that we have in our stocks can be anywhere. The average will be Q, the beginning point, the highest point, plus the lowest point, which is 0, divided by 2, i.e. Q over 2. So the average quantity held will be half of an order size, H times Q over 2. This is very important to get a feel for these this algebraic expression, this equation here, because it has a very simple application then in the course of determining the economic order quantity for a given situation. In other words, the economic order quantity Q becomes the unknown. So if we are to solve for Q, we need to set up our algebraic expression in such a way that recognizes that when ordering costs go up because we order more frequently, then holding costs are going to go down because we're ordering a smaller amount each time. This is the subtlety that we need to grasp in order to understand that the optimal order quantity, let's call it Q star, is where the ordering and the holding costs equal each other. In other words, where C times D over Q is equal to H times Q over 2, or this is the economic order quantity formula, which is used for such cases. The candidate is invited to apply this formula to the following example, which gives numbers, a scenario in which we have to solve for Q star. Now in this story here, weekly demand for the product is 500 units. We have to multiply this by 50 weeks. There's a standard year is 50 weeks. 50 times 500 units will be 25,000, and that will be equal to D. Notice that this meets the definition of D that we had talked about up here, quantity of product demanded annually. Here it is. If 500 units are required per week, 25,000 units are required annually, and that is equal to D. Now the purchase price of a unit is $15. That's P. The ordering cost, fixed ordering cost per order, How have we defined that? Just always check back here so that there is consistency in our definitions. The fixed cost per order is C. And the holding cost, which is defined by the cost of holding 1 unit for 1 year, is H. But we have to be careful here now, because we have to take this information, the 7% of the purchase price, and actually calculate the dollar cost of holding 1 unit per year. It would be 7% of P, 7% of the purchase price 15, or equal to $1.05. Now, that's our H. Remember, the economic order quantity formula is shown on the previous page. And we simply have to substitute now the numbers that we have derived from the scenario. So 2 times C, or $40, times D, very big number here, 25,000, divided by H, which is 1.05. Plugging those numbers in, we arrive at a Q which is equal to 1,380 units. Now, the interpretation of this is, if we order each time 1,380 units, we will minimize the combined purchase costs, ordering cost, and holding cost. That is the key to this formula. There is no other level of order quantity which will keep the total of the the ordering cost and the holding cost, that will reduce it further. And in fact, we can go further, and we can say that if we use 25,000 units in a year, and each time we order 1,380 units, we can conclude that the number of times we place an order during the year is around 18 times. And if we place an order 18 times during the year, then we can see that our ordering cost is going to be the ordering cost. We'll have a total of 18 times $40 per order, and that will be equal to $720. The holding cost we can also calculate from this scenario. If we order and receive 1,380 units, and we keep those units in inventory and we work them down to 0 before we order again up to 1,380, we can say that our average inventory level, remember, Q over 2 is going to be equal to 1,380 over 2, or 690 units. And each unit costs us $1.05 to hold it for 1 year. So our holding cost on this average inventory has to be multiplied 1.05 to give us $724. This $724, apart from a rounding difference, is virtually equal to the ordering cost of $720, which means that our total costs, leaving aside the purchase price and the cost of the materials themselves, because under all different scenarios P times D remains constant, so we can leave that aside, but the part which interests us is the total costs of, this is ordering plus holding, is equal to 720 plus 724, around about $1,440. That is as low as we can push those costs. There's no other level of Q which would result in the total of ordering cost and holding cost being less than 1,440. So this is really an optimal level that we have achieved.